Hello again. Let's look at some more examples. The fifth root of x to the fourth over the fifth root of x to the negative 1. Bring it together like this. And then remember, x to the negative 1 comes up here as x to the 1. The same thing that was true of square roots is true of fifth roots as far as the basic laws go. Fifth roots and square roots are different types of roots, but the laws apply to both, just the same. So what we do is I just bring x to the negative 1 up here. It's just x to the 1, which is x itself, and x to the fourth times x is x to the fifth. But the fifth root of x to the fifth is just x itself, and we're done. In a similar fashion, the fifth root of x to the fourth, this next problem, over the fifth root of x to the negative 6, you bring it together like this, and then the step that I keep skipping time and time again, but it shouldn't throw you off too much. You can probably tell what I'm going to do is I'm going to just insert the fifth root here, and well, that x to the fourth stays put. X to the neg 6 comes up as x to the positive 6, so you get x to the fourth times x to the 6, and then by the laws of exponents you add the 4 and the 6 and you get 10. Now x to the 10th, 10 divided by 5 is 2, and again we're assuming all variables are positive, okay? So it's x to the 2 power, and there's that. But anyway, later on we'll see that if we do odd roots, we don't really need that assumption, but let's just keep it for the time being, okay? I don't want to split hairs right now. Now here, the fifth root of, in a similar manner, you just have x to the negative 11 down here. You just bring it up, and you'll get x to the 15. I skipped this step here, but just do what I did up here. I'll leave that to you. Now remember, guys, like up here, we did 10 divided by 5 is 2, and way up here, we did 5 divided by 5 is 1, understood. Now here, 15 divided by 5 is 3. Okay, so there's that. Now, how do I handle one like this? The fifth root of x to the 7th. Now, we want to break up 7. The biggest multiple of 5 that will go into 7 is 5 itself. So we break up 7 into 5 plus 2. Now, the step that I sort of skipped, you may not appreciate me skipping it, but when everything was still together, we break up x to the 7th as x to the 5th times x squared. And then the whole point, 5 being the biggest multiple of 5 that goes into 7. Now, that x squared can't come out, remember? But now 5 divided by 5 is 1. So that just comes out as x itself, and we get x times the fifth root of x squared. Now, I skipped this step in between. Now, this step in between, some students don't like to take this step, but some students do. You can, by the law of fragmentation, the fifth root of AB is the fifth root of A times the fifth root of B. So you can break this up. That's the fifth root of x to the 5th times the fifth root of x squared. That's really the underlying belly of how this works. This kind of explains where it all comes from, why we do the whole 5 divided by 5 business. If you break it up like this, you can see the very definition of the fifth root of x to the 5th is x. That's what the fifth root does to you. And then the fifth root of x squared, we can't really, that's x to the 2/5 power, but that doesn't really do anything for me. Now, if your professor wanted this in exponent form, it would be x, it'd just be x to the 7/5 power. That wouldn't be very exciting. But the whole point of this was to have radical form. So let's just move on. X to the 7/5 power, that's not that exciting. Now, the fifth root of x to the 99, that's the fifth root of x to the 95 times the fifth root of x to the 4th. Now, guys, 95 divided by 5 is 19. And now we can't really, remember x to the 4th can't come out. 4, the power, is smaller than the index of 5. So that's stuck. And down here, 100 divided by 5 is 20. Game over. Or, yeah, that was unnecessary, wasn't it? I kind of wrote the same thing down twice. Oh well, let's just get rid of that. Yeah, that's kind of silly. But I tell you what you can do, an optional middle step, is you can turn this into exponent form. Exponent form is kind of nice. That's x to the 105th power. And then, but 100 divided by 5 is 20 itself. Just however you want to look at it, you can just do 100 divided by 5 and just cut to the chase and get x to the 20, or you can insert this middle step, just whichever you'd prefer. Now, if your professor makes you go a certain way, then, well, you'll have to go that way. But anyway. Now, here's the question. How do we handle a radical like a fifth root on the bottom? What if it's a root that's not a square root necessarily? What if it's like a fifth root? Well, how do we handle that? Let's see. And you know what? I made a mistake, guys. I'm catching some errors here. Sorry about that. So the 1 over the fifth root of x. The way I had it a minute ago had just been 1 over x itself. But I don't want to make it that nice. Let's do one that actually demands something of me. 1 over the fifth root of x. Now, and again, I made the same boo-boo here. I keep making mistakes. Okay. I'll correct this in the editing, and I need to correct the form that's in your that's in there now. But anyway, if I sent you the form. So now here's the dig. This is just x to the 1. I wish it was x to the fifth. Notice that I would need to multiply this by x to the fourth to make that come true. So what I do is I multiply another fifth root down here, and I do the fifth root of x to the fourth. Because I know that this will come together with this guy. We're assuming x is positive. Well, I don't really need that here, but anyway. X to the fourth, because it's an odd root, I don't need that. But let me get back to what I'm talking about. I know this x to the fourth will come back and multiply into this x and give me x to the fifth. And the fifth root of x to the fifth I know will be x, and I'll get what I want. Here, then here, then here. I can already see that. But there's a price you got to pay. If you multiply the denominator by the fifth root of x to the fourth, you have to multiply the numerator, which is 1 in this case, by the fifth root of x to the fourth. And that just is it, since that's a 1, that you just get itself the fifth root of x to the fourth. So multiply top and bottom by the fifth root of x to the fourth, which in exponent form, that's x to the power of 4/5. But anyway, there's that and that. Now, then I just get the same guy over, these come together, and as x to the fourth times x, which is x to the fifth. But I like that. That was the whole point, was to get just x down there. 5 divided by 5 is 1, x to the 1, and then there I am. So that's how you clean up a radical like that on the bottom, okay? Now, what if, instead of the fifth root of x to the 1, what if I have the fifth root of x cubed? Okay, and, well, what I do, notice that I wish this wasn't x cubed. I wanted it in my heart of hearts to be x to the fifth, even though it's not. It's just x cubed. But notice if I multiply x cubed by x squared, I'd get x to the fifth. So I insert the fifth root of x squared here. You could put it on, it's commutative. You could put it on the left or right side of this. You could put it here or here. So it's the fifth root of x squared here and here. Commutativity says you could put the fifth root of x cubed in front if you'd rather, either way, down here that is. Now you can't put the fifth root of x cubed upstairs. Don't do that. But so we got the fifth root of x squared here and here. And, well, that's going to make my dream come true. That's going to come together down here as the fifth root of x to the fifth. That's just x. Now upstairs I just leave it alone. It's just the fifth root of x squared. And if you love exponent form, like, if your professor allowed it or even insisted on it, it would be x to the 2/5 up top over x on the bottom. But anyway, there's that. Now, what if I go over 10? The fifth root of, well, we don't want to use 10 itself because that would just give me 1 over x squared. Like the fifth root of x to the 10 would be x squared. You do 10 divided by 5 is 2. And it'd be over with. It'd be 1 over x squared. But this is a 12. It's not a 10. Now, in my heart of hearts, I know, now 10 is out of reach. I've gone above 10. It's over. I've gone over. So I've got to look for the next multiple of 5, the smallest multiple of 5 that is bigger than 12, and that's going to be 15. I wish this 12 was a 15. I got to go up the rank, not down the rank. Okay. So x to the 12th, I know if I multiply that by x to the third power, I would get x to the 15th. So I insert times the fifth root of x to the third power. But if I multiply it down here, I got to multiply it up here. Now my numerator is not going to change. My dream comes true. This comes together as the fifth root of x12 times x cubed, which is x to the fifth root of x to the 15th. And remember, you do 15 divided by 5, and you get, oh my, that's not x. 15 divided by 5 is 3, isn't it? My bad. Sorry. So that's the fifth root. Excuse me. The fifth root is gone down here, so that's just x cubed on the bottom and the same old guy up top. I've caught myself making some silly errors here, and I'll correct those in the editing and all that. So there's that. I guess when I type so long, I get clumsy as all get out. But yeah, thank you for bearing with me. So we have all that, and I hope this helps. Let's look down here. 1 over the 6th root of 21. To be honest, guys, I tell you what you can do. It's sneaky. It's clever. Now, here we have to assume x is positive. We're doing an even root. But anyway, here's what's sneaky. 3 will go into 6 2 times. Notice that between 6 and 21, 3 is the greatest common the greatest common divisor, or the greatest common factor. So 3 will go into 6 2 times. 3 will go into 21 7 times. So this is really 1 over the square root of x to the 7th, because this can reduce to 2, divide by 3 and you get 2, divide this by 3 and you get 7. That's just a little sneaky trick. But I'll play by the rules for now. We'll keep it like this. Notice that if we keep it like this, well, 21 is not a multiple of 6. 24 is the next one in line, right? The smallest thing bigger than 21 that's a multiple of 6 is 24. So we need x cubed. So I need to multiply by x cubed. Multiply by the 6th root of x cubed. Cough, cough. That's really the square root of x, because you can reduce by 3. Remember, this is x to the 3/6 power, but that's a half. Indeed, you can divide this 6 by 3 and get 2, and divide this 3 by 3 and get 1 itself. So you'd have the 2 root of x to the 1. That's just the square root of x. But anyway, if you don't mind putting that on hold just for a minute. So this is the square root of x, but I want to write it like this. Keep it like this, okay, since we've stayed with 6 the whole time. Now we have x to the 3/6, which is x to the half. Now down here, these come together, we get the 6th root of x to the 24th. Oh, okay, but the 24 divided by 6 is x to the 4th. So that's just the square root of x over x to the 4th. It came out good after all. We're in fine shape.